Addressing electrical code compliance when connecting a detached garage to a house with the new building section presents several options. Firstly, consider the existing electrical system and any code violations. The original setup involved a meter-based main disconnect at the roadside pole with a 3-wire feeder to the house, supplied according to 250.32 B2, and a 4-wire feeder with equipment grounding separation to the detached garage, supplied according to 250.32 B1. Now, with the addition of a habitable section connecting the two, the primary concern is maintaining code compliance, specifically addressing 225.30, which deals with the number of feeders or branch circuits supplying a building. Several acceptable options exist to address this situation. Option 1 involves correcting the existing violation. This would entail installing a main overcurrent protection device at the point where the 3-wire feeder enters the house. Depending on the utility configuration, this could also involve installing a meter or main disconnect at the house. However, this option may require accessing and modifying the house's electrical system, potentially causing damage to finished surfaces, which is something to avoid if possible. Option 2 suggests creating a sub-panel in the new building section. This would involve installing a sub-panel in the new building section, fed from the existing garage sub-panel. A separate feeder from the garage to the new sub-panel with proper overcurrent protection would need to be installed. This approach avoids modifying the house's electrical system directly but may require trenching and extending the feeder from the garage. This option is beneficial because it leverages the existing infrastructure in the garage without disturbing the house. Option 3 is to extend the feeder from the house to the new building section. This would mean extending the 3-wire feeder from the house to the new building section. The existing feeder could be split at the point where it enters the house, routing one set of conductors to the new building section. While this avoids adding a new sub-panel in the new building section, it could require modifying the house's electrical system and accessing finished surfaces, similar to option 1. Considering the specific circumstances where the house is finished on all levels and accessing the main panel without damaging finished surfaces is impossible, option 2, creating a sub-panel in the new building section, is likely the most practical and least disruptive. It allows for the expansion without requiring modifications to the existing house. Option 1 may be the most difficult and disruptive, while option 3 is similar to option 2 but may require more labor and materials. Looking at it from the standpoint of future approach, when encountering similar situations, firstly determine the adequacy of the existing electrical system and identify any code violations. Secondly, explore solutions that minimize disruption to finished surfaces while complying with code requirements. Thirdly, consider the long-term implications of any modifications, such as potential future expansions or renovations. Also, consulting with other inspectors and industry professionals to gain a consensus on acceptable solutions is always a good idea. Code references to consider include 225.30 regarding the number of feeders on a building, 250.32 which addresses granting and bonding requirements for detached buildings, and applicable sections in Article 408 concerning switchboards and panel boards. When installing a sub-panel in the new building section, ensure that the feeder from the garage is properly sized and protected by an appropriately sized overcurrent device in the garage sub-panel. The sub-panel in the new building section must also have a main overcurrent protective device if it contains more than 6 branch circuits, according to NEC requirements. The equipment grounding conductor must be run with the feeder conductors from the garage to the new sub-panel, and the neutral and grounding bars in the new sub-panel must be kept separate. Bonding the metal enclosure of the new sub-panel to the equipment grounding conductor is also essential. If trenching is required to run the feeder from the garage to the new building section, ensure that the conductors are buried at the correct depth, as specified by the NEC, and protected from physical damage. When extending a feeder, proper wire sizing is paramount. Calculations must be performed per NEC Article 220 to determine the load requirements of the new building section. The existing feeder must be evaluated to ensure it can handle the additional load. If the existing feeder is undersized, it must be upgraded. Furthermore, any splices or terminations must be made in approved junction boxes and properly torqued to the manufacturer's specifications. When running conductors through walls or floors, ensure that they are protected from physical damage using appropriate methods such as conduit or sleeves. Also, follow the NEC guidelines for the support and securing of conductors. All work must be performed by qualified personnel and inspected by the local electrical inspector to ensure compliance with all applicable codes and standards. The electrical system should be thoroughly tested after the modifications are complete to ensure that it is safe and functioning properly. This testing should include verifying proper voltage, current, and grounding. In addition to the technical aspects, communication with the homeowner is crucial. Explain the different options, the associated costs, and the potential impact on their property. Obtain their consent before proceeding with any work. Document all modifications to the electrical system, including the size and type of conductors, the ratings of overcurrent devices, and the location of any new equipment. This documentation will be helpful for future maintenance and troubleshooting. If the new building section includes any special equipment, such as electric vehicle chargers or solar panels, ensure that the electrical system is designed to accommodate these loads. Consider the impact of the new building section on the overall electrical service to the property. If the load on the service is significantly increased, it may be necessary to upgrade the service to a larger capacity. When connecting the new building section to the existing electrical system, ensure that all connections are made in a safe and workmanlike manner. Use proper connectors and tools, and follow all manufacturer's instructions. Avoid overloading existing circuits. If necessary, install new circuits to serve the new building section. Use arc fault circuit interrupters, or RSIs, and ground fault circuit interrupters, or GFCIs, as required by the NEC to protect against electrical hazards. Label all circuits and equipment clearly and accurately. This will help to prevent confusion and make it easier to troubleshoot problems in the future. When working on electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize circuits before working on them, and verify that they are de-energized using a voltage tester. Be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. Remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes to ensure that your work is always compliant. By carefully considering all of these factors, you can ensure that the new building section is connected to the electrical system safely and in compliance with all applicable codes and standards. Remember to prioritize safety, communication, and documentation throughout the process. When evaluating the existing electrical system, pay close attention to the condition of the wiring, the age of the equipment, and any signs of damage or deterioration. Look for things like cracked or frayed insulation, loose connections, and corroded terminals. If you find any problems, they should be corrected before proceeding with the new building section. If the existing electrical system is old or outdated, it may be a good idea to upgrade it at the same time as the new building section. This can help to improve the safety and reliability of the electrical system, and it can also make it easier to accommodate future electrical needs. When selecting electrical equipment for the new building section, choose high-quality products that are designed to meet the specific requirements of the application. Look for products that are listed by a recognized testing laboratory such as UL or ETL. When installing electrical equipment, follow the manufacturer's instructions carefully. This will help to ensure that the equipment is installed correctly and that it will operate safely and reliably. Be sure to properly size the conductors for the new circuits in the building section, taking into account the ampacity of the conductors, the voltage drop, and the ambient temperature. Use the appropriate ampacity tables in the NEC to determine the correct conductor size. Properly terminate all conductors using approved connectors and methods. Make sure that the connections are tight and secure and that the conductors are not damaged during the termination process. Protect all conductors from physical damage. Use conduit, cable trays, or other approved methods to protect conductors that are exposed to physical damage. support and secure all conductors in accordance with the NEC requirements. This will help to prevent the conductors from becoming damaged or dislodged. Ground all metal enclosures and equipment in accordance with the NEC requirements. This will help to protect against electric shock. Test all circuits and equipment after installation to ensure that they are working properly. Use a voltage tester, an ammeter, and other testing equipment to verify that the circuits are properly energized and that the equipment is functioning as intended. Properly label all circuits and equipment. This will help to make it easier to identify and troubleshoot problems in the future. Provide the homeowner with a copy of the electrical plans and specifications for the new building section. This will help them to understand the electrical system and to maintain it properly. Be sure to obtain all necessary permits and inspections before starting any electrical work. This will help to ensure that the work is done safely and in compliance with all applicable codes and regulations. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Always prioritize safety when working with electricity and take all necessary precautions to protect yourself and others from harm. When dealing with an existing violation of 225.30, it's critical to ensure that the new building section does not exacerbate the non-compliance. The goal is to bring the entire electrical system, including the house, garage, and connecting section, into compliance with current codes while minimizing disruption and cost. In this case, adding a sub-panel in the new building section fed from the garage, option 2, offers a balanced approach. It avoids disturbing the house's finished surfaces while allowing for a code-compliant electrical supply to the new area. This approach aligns with the NEC intent to provide safe and reliable electrical systems for buildings and structures.